Hello and welcome to this lecture in domain-driven design. In the first part of this lecture, we are going to get a general overview where we are going to talk about domain-driven design, unified modeling language UML, and then Agile Software Development practices. As we will see, all three of these are connected. In the second part of this lecture, we are going to learn more about software development aspects in domain-driven design, and we're going to look at model-driven design, refactoring, and how to preserve model integrity. This lecture is based on two books, and these are Domain-Driven Design Quickly and UML Distilled. Both of these books are quite short and a nice reading, so I can definitely recommend you to read them. For those who want to dig deeper into the subject, I can recommend these two references. So with that said, we are ready to continue the lecture. Now we are going to talk about domain-driven design. So what is domain-driven design? Well, domain-driven design is a software design approach, and the main principle is that software should match a domain according to input from the experts in the domain. The subject area to which the user applies a program is what is called the domain of the software. So for example, if you want to create a software application for e-commerce, you need to understand e-commerce, which will be the domain. If you want to create a banking application, you need to understand banking, which will be the domain in that case. The term domain-driven design was coined by Eric Evans in 2003 when he released his book in the subject. In domain-driven design, the software needs to incorporate the core concepts and elements of the domain and to precisely realize the relationships between them. So we say that software has to model the domain. It is of course a challenge to know what the core is, and the perspective of the domain experts is important. I like to think of a map as a great example of a model. It is a simplification of reality, but users can plan their traveling very effectively. So this, I would say, is quite general for models. They are a simplification of reality, and you want them to be useful. Here I have included a quote from the book Domain-Driven Design Quickly, because I think this quote has a lot of good information that is worth thinking about. So I'm going to read the quote for you. According to Eric Evans, a domain model is not a particular diagram, it is the idea that the diagram is intended to convey. It is not just the knowledge in a domain expert's head, it is a rigorously organized and selective abstraction of that knowledge. A diagram can represent and communicate a model, as can carefully written code, as can an English sentence. So I think this quote contains a lot of good information, so I definitely recommend you to think about what it says. To model the domain, software developers and domain experts need to work together and communicate. Generally, there is a fundamental communication barrier since the language used by software developers and domain experts can differ. Software developers might use terminology, so software developers might use terminology such as relational databases, classes, functions, and so on. Domain experts in a bank, for example, might use terminology such as nominal interest rate, real interest rate, effective interest rate, continuous interest rate, and so on. By working together, a model can be created from which a common understanding and language can be developed. And this is called the ubiquitous language. The ubiquitous language should be used consistently in all communication by everyone involved. So now we're going to look at a conversation example of how it might look in reality. So we have John, who is a banker, and he talks to Lisa, who is a software developer, and John has an idea to develop the banking application. So I'm going to read the dialogue or conversation for you. So John says, "We would like our banking customers to be able to see the interest rate in their mobile app." Lisa answers, "They already see the interest rate for their account when they log into the app and look at their account details." This is the nominal interest rate. So there are different kinds of interest rates. Yes, we most often work with the interest rate types that are called nominal interest rate and real interest rate. The real interest is adjusted for the inflation. In our team, we are a bit sloppy, but we know from the context which one we are meaning. I understand. In our database, we have one column called interest rate and one column called inflation. Great. Then that can be used to calculate the real interest rate. The conversation continues, and together they sketch a graphical model of what features they want in the app. And this sketch, or the graphical model, could look something like this. So we have the banking application, and in the banking application, customers can log in, but also companies can log in. In the application, the user can look at account details such as real interest rate, nominal interest rate, and their balance. And in the app, you can also do some kind of loan application, which can be accepted, declined, or the bank can request more information. So this is a graphical representation of the model that John, the banker, and Lisa, the software developer, together developed. In the dialogue between Lisa, the software developer, and John, the banker, Lisa has obtained domain knowledge, and they together built a model which shows the core elements and the relationships between them. The ubiquitous language is based on the model and should be used consistently in all communication. So for example, interest rate should not be used. Instead, we should use real interest rate or nominal interest rate, since that is what is used in the domain model. So if we look at the sketch in the previous slide, we see that in this sketch we have real interest rate and nominal interest rate. And since this language is used in the model, that is the language that should be used in the communication. And this is then an example of the ubiquitous language. A diagram can help communicate a domain model, and the Unified Modeling Language, UML, provides a formalized way of doing diagrams. In reality, it is most often used as a sketch for discussions and creation of mutual understanding, meaning that the UML standard in many situations is not and do not have to be rigorously followed. So more formally, the Unified Modeling Language, UML, is a general-purpose visual modeling language that is intended to provide a standard way to visualize the design of a system. UML has many types of diagrams, which can be divided into two categories, which are behavioral UML diagrams and structural UML diagrams. The most frequently used diagrams are those that are called class diagrams and sequence diagrams. UML can be used to model a software system, for example, classes used in a program, or to understand a domain such as how banking works. UML can be used as a sketch or as a blueprint, and when used as a sketch, it helps to communicate some aspect of a system. UML sketches can be used in a forward engineering direction before the writing of code. This facilitates discussion and understanding about what we are going to do. UML sketches can also be used in a reverse engineering direction after the writing of code. This is used to understand or explain an existing system. When UML is used as a blueprint, the goal is to have a complete model. When blueprints are used in a forward engineering direction, the idea is that the code developed later on could be based on the blueprint. When blueprints are used in a reverse engineering direction, the aim is to convey detailed information about the code. Sketches are informal and dynamic, done quickly and collaboratively. Common mediums are whiteboard or paper, and if you draw on a computer, Miro boards can be a useful tool. So let us look at how a Miro board can look like. So I will go to the internet, and here we are on the Miro website, and we can for instance see the model that we used before. And I also demonstrate that you can insert different kind of figures and the like. So for example, if I would like to insert an arrow, I can go here and then, for example, use this. So there are many things you can do in a Miro board. Blueprints are formal, and tools such as Microsoft Visio, which is a proprietary tool, or Plant UML, which is an open source tool, can be useful. So if we look at Plant UML, so once again I go to the internet and then I go to the website plantuml.com, and here on this website you can learn more about Plant UML. So for example, you can read this getting started, or you can read some guides. Here I will go to the online server. So I press here the online server, and here I can paste in some Plant UML code that I have prepared. So let's see if I didn't copy it, so I will go to the slide and I will borrow this code here. So I borrow this code and go to the internet again. So if I paste in this code here and then submit the code, we see that here we have created a Plant UML diagram, or simply a UML diagram. So by using Plant UML, we can create formal UML diagrams. And I leave the details for you to explore. So if we now go back to our PowerPoint, and here, so as I said, blueprints are formal, and tools such as Microsoft Visio and Plant UML can be useful. In general, it's good to know that in reality, sketches are much more common than blueprints, and in reality, most practitioners actually do not need to use, and do not know how to use UML as a detailed framework, because sketches are the main purpose. Instead, informal hand-drawn diagrams are used, which often include elements from the UML. The official documentation has around 800 pages and is in general quite hard to learn, and it can be a time-consuming activity, meaning that it is not worth to do for very many people. So even though this is inconsistent, this is in itself not a bad thing, because sketches aim at facilitating discussions and understanding of something, and in this case, this is more important than producing correct UML diagrams. So for example, if a company wants to buy a custom-made software product, it could give a detailed blueprint following UML standards to an external company. In this case, probably the UML standards should be followed rigorously. If an internal team wants to discuss and understand something, iterative sketches can be used, and in this case, it is not that important to rigorously follow UML standards. Here on this slide, I show some example of Plant UML code, and you can copy this code and experiment with it, and this code would produce this class diagram. In the next slide, we have some Plant UML code here, And this code produces this UML diagram, which is an example of a sequence diagram. So check out the Plant UML website and do experiment with the code. Now we are going to talk about the Agile Software Development. So what is Agile? Agile is an umbrella term covering many processes that share a common set of values and principles which are stated in the Manifesto for Agile Software Development. The Agile Manifesto is comprised of 4 foundational values and 12 supporting principles. We can read the Agile Manifesto at this link. So I will go to the internet. And here on this link, we see that we have the Agile Manifesto. And the 4 foundational values we can read here. And the values say that individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. And they also say that while there is value in the items on the right, so these here, we value the items on the left more. So even though processes and tools are important, they value individuals and interactions more. So this is the 4 foundational values. If we go down at the website, we also see that we can, for example, read more about the authors and about the manifesto. And here we have the 12 principles of Agile software. So if I go here, we see that we have the 12 principles. And one of the principles says that business people and developers must work together daily throughout the project. And this is a very central topic in domain-driven design, meaning that domain-driven design fits nicely together with Agile software development, and they are very tightly connected. If we continue to scroll down the page, we see that there are more principles. And one of my personal favorite is this one. And it says that simplicity, the art of maximizing the amount of work not done, is essential. So this is the website of the Agile Manifesto, and I definitely recommend you to look it through. If we go back to our PowerPoint, so as I said, the Agile Manifesto is comprised of 4 foundational values and 12 supporting principles, and you can read about it here on this link. And we also saw that one of the principles was that business people and developers must work together daily throughout the project. And this is then an essential ingredient in the domain-driven design approach, meaning that domain-driven design and Agile fits together very nicely. Many different Agile frameworks exist, and Scrum, Extreme Programming, and Kanban are 3 examples. So let us look at these. So the essence of Scrum is that work is broken into goals to be completed within time-boxed iterations, which are called sprints. Progress is assessed in a daily meeting of up to 15 minutes, and these meetings are called daily scrums. After a sprint, the team holds 2 meetings, one to demonstrate the work done for stakeholders and get feedback, and one internal sprint retrospective to reflect and learn. The Scrum Master is in charge of the Scrum team, and the product owner focuses on the business side of product development and spends the majority of time liaising with stakeholders and the team. The product owner is responsible for the product backlog, which is a breakdown of work to be done and contains an ordered list of product requirements. If you want to read more about Scrum, you can do so at the Scrum Guide, available here on this link. Extreme Programming takes its name from the idea that beneficial elements of traditional software engineering practices are taken to extreme levels. As an example, code reviews are considered a beneficial practice, and taken to the extreme, code can be reviewed continuously, which is achieved by the practice of pair programming. And pair programming is when two programmers work together at one workstation. The driver writes code while the observer or navigator reviews each line of code as it is typed. The two programmers switch roles frequently. Some elements of extreme programming include pair programming, unit testing of all code, a flat management structure, code simplicity and clarity, expecting changes in the customer's requirements as time passes and the problem is better understood, and frequent communication with the customer and among programmers. Kanban comprises the following three practices working in tandem. So one is defining and visualizing a workflow, actively managing items in a workflow, and improving a workflow. So one central tool in the Kanban philosophy is the Kanban board. And this is widely used within different IT teams. If you want to read more about Kanban, you can do so at this guide available in this link. And I can also say that a combination of Scrum and Kanban is called Scrumban. So now we have talked about Agile methodologies, and of course there are also alternatives to Agile ways of working. So Agile is characterized by an iterative way of working, and this can be compared with the waterfall model. The waterfall model is a breakdown of development activities into linear sequential phases. So for example, we might work in the order of requirement analysis, design, coding, and then testing the code. We might, for example, spend 3 months for each phase if the total project length is 12 months. In the iterative approach, the first iteration could use 3 months on working with a quarter of the requirements and the complete software cycle of analysis, design, code, and test. In the next iteration of 3 months, we could continue and would then theoretically have a system that does half of the functionality required in the requirements. The general question of how to work is a long and interesting discussion, and we conclude shortly by saying that different organizations work in different ways with varying results. So far, the main message in domain-driven design is that we want to create a model that is deeply rooted in the domain, and it should reflect the essential concepts of the domain with great accuracy. All communication should also be based on the ubiquitous language which is derived from the model. Once a good domain model is in place, the next step is to implement it in code. So, creating a domain model can be done in 2 ways. The first way is that the domain model is built without consideration to software design. And the second way is that the domain model is built with consideration to software design. The second approach is the recommended one, because in practice, the model built with the first approach has a high risk of living its own life, since transition from domain model to code is far from trivial. The software developers will be forced to make design decisions in regard to what is possible to code and performance aspects. Often, they also have to make assumptions about intended behavior. When decisions have been made that is not part of the domain model, a discrepancy between the model and the code design is created, and the domain model becomes less relevant. This is bad since the domain model risks of becoming totally irrelevant. So, to summarize, closely relate the domain modeling and code design. Developers should be included in the modeling process of the domain rather than getting a text and a diagram of what should be coded after the domain model has been created. To tightly tie the domain model to code design requires software development tools and languages that support a modeling paradigm. Object-oriented programming does this. Object-oriented programming provides classes of objects and associations of classes, object instances, and messaging between them. Object-oriented programming languages makes it possible to create direct mappings between domain model objects with their relationships and their programming counterparts. Procedural languages, in contrast to object-oriented programming languages, offer limited support for model-driven design and is therefore not recommended. The figure here shows some important patterns and their relationships that are used in model-driven design. So for example, if you want to do model-driven design, you can express a model with services, entities, value objects, and you can, for example, isolate a domain with layered architecture. I will not go into details about this, but if you want to learn more, I can recommend the book Domain-Driven Design quickly. Now we are going to talk about refactoring. So we have expressed the importance of creating a domain model which expresses the domain and that code design should be a part of this modeling. A great domain model that is not possible to implement in code would be of little use. During the design and development process, it is often necessarily and a good idea to have a break and look at the code. It may be time for a code refactoring. Code refactoring is the process of redesigning the code to make it better without changing application behavior. This is often done in small, controllable steps with great care so we do not break functionality or introduce new bugs. Automated tests are very helpful in this context. When new insights regarding the domain, perhaps a new relationship or element is discovered or understood more clearly, then refactoring with regards to the domain model can be done. Sophisticated domain models are seldom developed without an iterative process of refactoring where domain experts and developers are both closely involved. We are now going to look at how we can preserve model integrity. So, domain-driven design is against the idea of having a single unified model. And the reason is that a big model is hard to understand in its whole, and if a developer, for example, makes a change or adds some functionality to the code, it will be hard to understand the consequences on the model as a whole. Multiple people involved also creates a coordination difficulty, and different teams working with the same big model in parallel also adds complexity. So the solution is to divide a large model into what is called bounded contexts, each of which has their own model. The relationships between models should be defined with precision through context maps. So if we look at this figure here, then we see some techniques and the relationships used to maintain model integrity. So for example, we have different bounded contexts, and the relationships between them are defined by context maps, and there are different kinds of context maps such as shared kernel, customer-supplier teams, and so on. I will not go into details about this, but if you're interested to learn more about it, you can read the book Domain-Driven Design quickly. So with that said, we have come to the end of this lecture. Thank you for watching. Bye.